Hello friends, Mr. Burrell here. We just finished with Unit 11 talking about trigonometry, evaluating and solving trigonometric functions. Now we're getting into the trigonometry unit on graphing. So we're going to be graphing trigonometric functions. In the past, just in this trimester, we've talked about graphing logarithmic functions, exponential functions, and the transformations associated with those. We've talked about graphing radical functions and the transformations associated with those. In the past, you've talked about graphing all sorts of different kinds of functions, linear functions, quadratic functions, even like absolute value functions, lots of different types of functions you've talked about how to graph. So now we're going to talk about graphing trigonometric functions. So as per usual, we're going to start with talking about parent trigonometric functions. So by the end of this lesson, let's go next here. By the end of this video, this is what I hope you're able to do. I want you to be able to graph the parent functions of sine, cosine, or tangent in degrees and in radians. And we'll talk about what that means here in a bit. And I want you to be able to identify the parent function from a graph. So you'll notice here, I have this outlined as unit 12.0. So it's kind of a pre-unit to what the homework assignments are going to be. So the homework assignment for this unit, what I want you to upload is the sheets from the guided notes associated with this concept. So there won't be a homework assignment, but what you do, the work you do to follow along with what I do in the video, that's what I want you to upload to Canvas. Okay. So this is what we're going to start with. I'm going to go ahead and make this fit in the screen as best as I can. And I'm going to move this guy over here. So I have a table of basically x and y values. So you could consider this our x, and this our y, this our x, and this our y. So I'm going to start by doing all of these in degrees because that's, I feel like, where we're the most comfortable. So I have theta being the angle in degrees. So I have 0 through 360 degrees and then 0 through negative 360 degrees. So that's going to represent my x-axis here. And then the result, so when we're going to start with the sine function. We're going to be doing sine, cosine, and tangent. We're going to start with the sine function. So we're going to write the decimal values for the sine of each of these angles in this box, and then we're going to use those values to graph on this grid. So I'm going to go ahead and mark these each as 0.25, and you'll see why in a minute. So this is 0.25, 0.5, 0.75, and 1, negative 0.25, negative 0.5, negative 0.75, and negative 1. You'll see why in just a little bit. So we should know all of these values given our unit circle. In the last unit, we talked about the unit circle, and we talked about the sine values for every single one of these angles. They were the y-coordinate on my unit circle. But I want these all in decimal form because that's going to make it easier for me to graph them on this grid. So if you have a calculator, if you're using Desmos, whatever you want to, we're going to go ahead and type into our calculator sine of each of these angles. And I've done that in my calculator, so I'm going to go ahead and fill them in. So sine of 0 is 0, sine of 30 is 0.5, sine of 45 is 0.707, sine of 60 is 0.866, sine of 90 is 1. Okay, we've gone through the first quadrant of the unit circle. Sine of 120 is 0.866. Sine of 135 is 0.707. Sine of 150 is 0.5. Sine of 180 is 0. Well, look at that. Kind of like a little boomerang effect. Okay, and now let's go on. Sine of 210 degrees is negative 0.5. Sine of 225 degrees is negative 0.707. Sine of 240 is negative 0.866. Sine of 270 is negative 1. Sine of 300 is negative 0.866. Sine of 315 is negative 0.707. Sine of 330 is negative 0.5. And sine of 360 is 0. So this is going to be the right half of our grid. So this is what I want you to be writing down in your grid, either on guided notes or on a piece of paper, whatever it may be. Okay, so when x is 0 or when theta is 0, y is 0. So I have this point right here. And then I'm going to go ahead, this is 30 degrees, 60 degrees, 90 degrees. So at 30 degrees, I have 0.5. At 45 degrees, I have like 0.707. 60 degrees, I have 0.866. And then 90 degrees is 1. 120 degrees is 0.866. And then 0.707. 0.707. 0.5, and then 180 degrees is 0. Look at that nice little shape. 210 degrees, so this is 210, this is going to be 240, so 210 is negative 0.5, and negative 0.5, negative 0.707, negative 0.866, and then negative 1, negative 0.866, negative 0.707, negative 0.5, and 360 degrees is 0. So this side of my graph kind of looks like, if I connect the dots here, kind of looks like that. Little mountain and a valley situation. Okay, now what do you think, just think in your brain here, where do you think this is going to go in the negative direction? I went kind of through this full up and down back to the x-axis over 360 degrees. What do you think is going to happen on the left side here? Well, let's check. Sine of 0 is 0. Sine of negative 30, sine of negative 30 is negative 0.5. Sine of negative 45 is negative 0.707. Sine of negative 60 is negative 0.866. You see where I'm going with this? These are all the opposites of the sines of the negative angles, are the opposites of the sine of the positive angles. So here I'm going to have negative 1, negative 0.866, negative 0.707, negative 0.5, 0, positive 0.5, positive 0.707, positive 0.866, positive 1, positive 0.866, positive 0.707, positive 0.5, and back to 0. So this side, I'm going to draw a rough sketch here. This side is going to look something like, oh man, like that. Something like that. So, we've done step 1, we've done step 2, we've plotted these points as accurately as we can on the x and y axis. So that is my sine parent graph. Step 3 says check your graph in a calculator by graphing f of x equals sine of x. If you do this in a graphing calculator like one that I had at the school, you'll want to make sure that your calculator is in degree mode and that your window at the very top of your calculator, there's a little window button. You'll want to make sure that your window will span between negative 360 and positive 360. But what I have done is I have went ahead and graphed this in Desmos. And in Desmos here in the settings up here in the corner, you can change how far your x-axis and your y-axis are. So I made my x-axis between negative 360 and positive 360, and my y-axis just between like negative 5 and positive 5. So I've graphed y equals sine of x. And look at that. It's this nice little wave, this nice little sine wave. And you'll notice as I keep going to the right, it just keeps repeating itself. Just keeps repeating itself over and over and over and over and over. Okay, so that's my sine function. We often refer to that as a sine wave. So here, step 4 says brainstorm the answers to the following questions with your partner. These questions down here. You don't have a partner, I'll be your partner. It says after how many degrees does the graph start repeating itself exactly? So you notice I go up, down, and then back to the x-axis, all over the span of 360 degrees. From here I went down, up, and then back down to the x-axis over 360 degrees. So it takes 360 degrees for this graph to repeat itself. Then it says how, I'm going to say 360 degrees, how high or low does the graph actually deviate from the x-axis? Well, at its highest point anywhere on the graph, I only go as high as 1. So I go as high as 1 on the y-axis. And then I go as low as -1 on the y-axis, if you see that. So the farthest that I get away from the x-axis going up and down on the y is 1 unit in either direction. So that's a sine function. That's a sine wave. Let's move on to cosine. So we're going to whiz through this one relatively quickly. But cosine of 0 degrees is 1. Cosine of 30 degrees is 0.866. Cosine of 45 degrees is 0.707. Cosine of 60 degrees is 0.5. Cosine of 90 degrees is 0. You sense any patterns here? Cosine of 120 degrees is -0.5. Cosine of 135 degrees is -0.707. Cosine of 150 degrees is -0.866. Cosine of 180 degrees is -1. Guess what? This is going to repeat itself again. So I'm going to have -0.866, -0.707, -0.50, and then 0.5, 0.707, 0.866, and 1. Okay, so now I'm going to plot these points on here. 0 degrees, I'm going to again span up to 1 so I can have some space here. So here's cosine of 0 degrees at 1. Cosine of 30 is 0.866, then 0.707, 0.5, and cosine of 90 degrees is 0. Cosine of 120 is -0.5, and then -0.707, -0.866, and then 1. This isn't perfect science, but my cosine wave, or my cosine function, is going to look something like that. If I keep going, my cosine function is going to look something like that. And guess what? On the other side, it's going to repeat and do the exact same thing. Again, I'm not a perfect artist, but that's pretty darn good if I do say so myself. So I'm going to go ahead and drag my Desmos graph over here again, and you can fill in the rest of these spots typing in those values into your calculator. This should say cosine at the top. I apologize that I left those saying sine. If I drag my Desmos graph over, I'm going to drag my face out of the way here and change over here to the cosine function. Look at that. It starts up here. Instead of starting at 0 like sine did, cosine is going to start at, it starts at 1, and then it kind of follows the same pattern as sine. It goes up and down, up and down, up and down, all the way on forever and ever. But it's almost like it's been shifted to the right or to the left a little bit. So it starts at 1, goes down, and then repeats itself. So it starts at 1, goes down to -1, and then ends up back at +1 at 360 degrees. So it takes 360 degrees for me to make a full kind of cycle through this cosine wave from top to bottom, back to the top again. 360 degrees it takes to go through that full cycle. And it keeps going. Every 360 degrees it repeats itself. And notice that the highest that it gets on this graph is 1 on the y-axis, again, just like the sine wave, and the lowest it gets on this graph is -1, just like the sine wave. So, here we're asked these other questions again. How many degrees does the graph start repeating itself? Exactly, well, 360 degrees. How high or low does the graph actually deviate from the x-axis? Well, 1 up and 1 down. So the cosine and the sine functions are really similar to each other when I graph those on a plot, and they just keep repeating itself forever and ever and ever. Okay, so we just finished talking about sine and cosine. Let's talk about tangent. Let's talk about tangent. What do we think these are going to look like? Do you think tangent functions will look similar? Do you think they'll look different? Let's check. Okay, again, up here, these should say tangent. I don't know why they don't. Actually, I do. It's because I forgot to change them. So let's fill in my plot here. So tangent of 0 is 0. Tangent of 30 is 0.577. Tangent of 45 is 1. Tangent of 60 is 1.732. Tangent of 90. Whoa! What is tangent of 90? Undefined. It gives you a domain error for tangent of 90 degrees. And if you look at your unit circle, that's what you would have or should have expected, that the tangent of 90 degrees is undefined because you divide by 0. Okay, so maybe this isn't going to be exactly like a sine or cosine function. Let's keep going. Tangent of 120 degrees is negative 1.732. Tangent of 135 degrees is negative 1. Tangent of 150 degrees is negative 0.577. Tangent of 180 degrees is 0. Tangent of 210 degrees is 0.577. Tangent of 225 degrees is 1. Tangent of 240 degrees is 1.732. Kind of see the pattern that's going on here? 0, 0, 0.577, 0.577, 1, 1, 1.732, 1.732. Let's see, what's the tangent of 270 degrees? Oh my gosh! It's undefined! We expected that from our unit circle. We expected the tangent of 270 degrees to be undefined. Tangent of 300 degrees is negative 1.732, and guess what? This is going to be negative 1, negative 0.577, and 1. Okay, let's plot some of these points on my graph. So I have 0, 0, 30.577, so that's up here. Again, this is going to be 1, and then this is going to be 0.25, 0.5, 0.75, 1.25, 1.5, 1.75, etc., just so I have some space. Okay, I'm going to go ahead and pull this down real quick. Okay, so 30 degrees is 0.577, 45 degrees is 1, 60 degrees was 1.732, so it's like clear up here. And then 90 degrees was undefined. Guess what that's going to be? That's going to give me an asymptote. I'm going to have an asymptote at 90 degrees because it's undefined there. 120 degrees, I'm going to have negative 1.73. That's clear down here. 135, I'm going to have negative 1, which is right here. And then 150, I'm going to have negative 0.577. Then 180, I'm going to have 0. And then again, I'm going to have 0.577, 1, 1.732, and an asymptote at 270 degrees. Do you see what's happening? Do you see what's kind of happening? 300 degrees, I have negative 1.732, and then I have negative 1, negative 0.577, and 360 degrees is, that should have been 0. Right, tangent of 360 degrees is 0. Thanks for the catch, Mr. Burrell. Okay, so if I'm going to plot, kind of connect the dots on some of these points, kind of have this little curvy S-shaped situation. And guess what? If I go on this side, I'm going to have an asymptote at negative 90 and at negative 270. And I'm going to draw kind of a rough sketch here. But the left side of my graph is going to look like that. Look at my tangent function. What's going on here? That's crazy. That's so unlike my sine and cosine functions. Okay, I'm going to go ahead and graph this in my graphing calculator. I'm going to drag my Desmos graph over here. Make sure that we're on the right page, that I didn't do something crazy. Let's graph tangent. Yeah, so it's kind of these S-shapes with asymptotes at 90 degrees, 270 degrees, negative 90 degrees, and negative 270 degrees. So every 180 degrees, I have an asymptote. So 270 plus 180 is going to be 450. I have another asymptote that the graph's not going to touch, etc., etc., etc. It just keeps repeating itself forever and ever and ever. Sine, cosine, tangent. Holy smokes. That's crazy. Okay, So let's look at this. Let's brainstorm some of these questions. After how many degrees, after how many degrees does the graph start repeating itself exactly? Well, there's an asymptote every 180 degrees. This graph is going to start repeating itself every 180 degrees. Sine and cosine functions were repeating themselves every 360 degrees. The tangent function is repeating every 180 degrees. And how high or low does this graph actually deviate from the x-axis? Well, spoiler alert, these functions, these graphs are going to keep on going forever and ever and ever, up and down. So they never end. There's not going to be a maximum point and there's not going to be a minimum point. So no max and no min. And again, these are the things that I want you to have written down either on a piece of paper or in those guided notes to submit on Canvas with these tables filled out. Just following along with what we're doing here. Okay, I'm going to go on here. Now that we've looked at all of these different functions, and I might pull the Desmos graph over so we can look at them a little bit more, what was the difference between the sine and cosine graphs? Let me pull this over. What was the difference between the sine and the cosine graphs? Well, you'll notice if I were to drag this cosine graph, drag it over, it would be the exact same as the sine graph. It's just shifted. It's kind of shifted over to the left here a little bit. This one starts at 0, 1. This one starts at 90 and 1. So it's shifted over by 90 degrees. So the sine and cosine graphs, what's the difference? They're shifted. They're shifted horizontally. They're shifted horizontally or from left to right by 90 degrees. Or in radians, by pi halves. And we're going to look at that in just a minute. If we're talking in degrees, that's going to be shifted by 90 degrees. In radians, that's shifted by pi halves. What were the similarities between the sine and cosine graphs? Well, they both repeat themselves after 360 degrees. They both repeat themselves after 360 degrees. And they both reach a maximum point of y equals 1 and a minimum point of y equals -1. So let's look at this. They both repeat themselves over 360 degrees. So notice my sine function started at 0, went up, down, and then back to 0 again over 360 degrees. My cosine function started at 1, went down, back up, and hit +1 at 360 degrees. And they both never get higher. If I were to draw a line right here at 1 and -1, they never get higher than +1, and they never get lower than -1. So those are some of the similarities between the sine and cosine graphs. Okay, so here are my sine and cosine functions. The sine function is the solid red line. The cosine function is the dotted blue line here. So here's some terminology that we're going to use in association with these graphs throughout this unit, these next couple lessons. The midline, or the line right through the middle, the horizontal right through the middle of these sine and cosine functions, is at x equals 0. So it oscillates, that's a fun word, right around the x-axis. It goes up to 1, down to -1, with a midline right at x equals 0. The amplitude is 1. So the distance from that midline to either a crest or a valley, the distance from the x-axis to the maximum or the minimum points, is 1. So the amplitude of the sine and cosine functions is 1. The period is the word for how long it takes for the sine or cosine wave to make a full cycle. So we talked about how it takes 360 degrees for a sine or cosine wave to go through a full cycle. Or in radians, it takes 2 pi radians to go through a full cycle. So you notice this x-axis is defined in radians. So it takes 2 pi radians or 360 degrees to make a full cycle or a period. The domain of this function, so all the possible x values, is everything from -infinity to +infinity, because I showed you on the graph that it keeps going forever and ever and ever in both directions. And the range is from -1 to +1, because I never get lower than -1, and I never get higher than +1. So those are some of the characteristics of my sine and cosine functions. They both have a midline at x equals 0, an amplitude of 1. Again, the amplitude is the distance from the x-axis to either a crest or a valley. They both have a period of 360 degrees or 2 pi radians, meaning that's how often they repeat themselves. They have a domain from negative infinity to positive infinity and a range from negative 1 to positive 1. Now, let's look at the tangent function. So my tangent function, the midline, again, I have the same midline as my sine and cosine functions at 0. So you notice where they kind of change directions here is at the x-axis here. So the midline is still at x equals 0. The amplitude, there is no amplitude because there's no maximum or minimum value. So I can't really measure the distance from the x-axis to a maximum because there is not a maximum or a minimum. The period, or how often this graph repeats itself, is 180 degrees, or pi. So you notice here I have, say, from pi halves to 3 pi halves, I have this distance where I have a full tangent wave you can kind of think about. And then from 3 pi halves to a full pi after that, 5 pi halves, my graph repeats itself again. Or from pi halves to negative pi halves, it repeats itself again. So the period of a tangent function, or how often that function repeats itself, is pi, or 180 degrees, where the tangent function goes through 0, goes through pi, goes through 2 pi, etc., etc. The domain of a tangent function is kind of unique because the domain is everything except for pi halves, 3 pi halves, 5 pi halves, 7 pi halves, 9 pi halves, negative pi halves, negative 3 pi halves, negative 5 pi halves, negative 7 pi halves. The domain is all real numbers except for each of these asymptotes. And then the range, so everything going up and down, is from negative infinity to positive infinity, because we mentioned that a tangent function doesn't have a minimum, doesn't have a maximum, it just keeps going forever and ever. So those are some of the characteristics of some of these parent trigonometric functions. Again, if I want to show you on Desmos, this is my sine function, starts at 0 and goes up to 1 and down to negative 1, making a full cycle every 360 degrees. Cosine starts up here at 1 and cycles through a full cycle over 360 degrees and ends up at 360 and 1. Tangent starts at 0, kind of goes through 0 degrees, 180 degrees, and 360 degrees, repeating itself every 180 degrees with asymptotes at 90, 270, every 180 degrees. So those are the parent sine, cosine, and tangent functions. Hopefully you're able to graph those now in specifically degrees, and then when we graph those in radians, we just replace, again, convert those degree measures into radians. And hopefully, if I were to give you a trigonometric graph, you'd be able to identify if it was a sine, cosine, or tangent graph. So in the coming lessons, we're going to talk about transforming these functions and how to graph those transformations and how we do that. So I hope this video was helpful. If you have any questions, please don't hesitate to reach out. Again, your submission for this assignment is going to be the pages from the guided notes associated with this concept, or your sketchings on a piece of paper or a whiteboard or whatever you end up doing for the guided notes for this section, what you followed along with. So I hope that was helpful, and I hope that you enjoyed that as much as I did.